Hello students, today in your calculus class we are going to go over yet another derivative rule. This one's called the chain rule. So let's go ahead and get started. Go ahead and try this warm up on your own and we'll come back in a second. Hopefully you pause your screen and you're just coming back to check your answer. Now this should be a pretty easy problem, probably just take a little bit longer because it's a quotient rule. So let's try that now. So remember, quotient rule we need to do low, d high. So we're going to take derivative of the top. So that becomes secant squared x minus high d low. So that's 1 minus cosine of x, all divided by low squared. So remember, this is over a fraction. So we're going to throw that fraction bar in real quick. And now we have to simplify this. So keep in mind, before I expand the bottom, I'm going to leave it alone for now because I'm going to see what the top looks like. So when we do that, we know that secant squared x is really just 1 divided by cosine squared x. But let's just leave it the way it is for now. So that's x times sine of x, or x times secant squared x minus sine x secant squared x minus, I'm going to put these in brackets because we have a big quantity. We're going to end up having 1 minus cosine x plus tan of x minus sine of x. Notice how that last one should have said something like tan x times cosine x, but keep in mind that tan x is sine x divided by cosine x, so we can cross cancel there. Again, this is all divided by x minus sine squared x. So we're going to go ahead and simplify this a little bit further. We're going to have x secant squared x minus sine of x secant squared x minus 1 plus cosine x plus tan of x minus sine of x. Oh, my apologies. I'm supposed to distribute that negative in the front of the bracket to everything. So that should be plus cosine x minus tan x plus sine of x. So this is what our equations are looking like. Trying to see if there's anything that we can cancel out here, and unfortunately there's not. And then we are still left with x minus sine squared x on the denominator. And that's going to be your derivative for now. So let's try the moving forward. So again, we're going to talk about the chain rule in this section. So the chain rule is just a compilation of the rules that you already have, but sometimes you're going to have these composite functions. So a function within a function. So you may have something like f by g of x. And so the chain rule states that if you have f by g prime of x, that's equal to f prime of g of x times g prime of x. So we multiply by the derivative of what's inside. So let's do one together, and we'll do it slowly. Now, see here we have cosine x cubed. Now I'm going to write this like an equation, or a little bit more of a composite function. So we have cosine of x cubed. Now, when we find the derivative for this, we're really finding the derivative of each piece. So we have cosine, that's our first function. Our second function is x cubed. So when we take the derivative of cosine of x, that becomes sine, negative sine. The inside stays the same. What we have to do after, let me get back into this editing. What we have to do after to complete the chain rule is multiply by the derivative of the inside. So the derivative of the x cubed is 3x squared. So your final answer should read negative 3x squared sine of x cubed is your final answer. So let's try another one together. So we have the quantity x squared minus 3x plus 1 to the fifth power. So I'm going to write that one out really quick. We have x squared minus 3x plus 1 to the fifth power. Now again, to find the derivative of this function, we need to first look at this a little differently. So actually, let's go ahead and introduce the u substitution now. So we're going to introduce something called u substitution, and that's basically when we let u be equal to a more complicated function, so the rest of it looks pretty easy. So we're going to say let u equal x squared minus 3x plus 1. Now, if we let u equal that, then we know that du is equal to the derivative of u is 2x minus 3. Now, using u substitution, what we're going to do here is we're going to go back to the original equation. Now, x squared minus 3x plus 1, that's equal to u. So we know how we have u to the fifth power. Now, when we find the derivative, so when we find the derivative of this stuff, we end up having 5u to the fourth power. But remember, chain rule says we have to multiply the inside of, we need to multiply by the derivative of the inside. So that's actually u prime, or rather du. So we end up with 5u to the fourth times du. Now we know what u is, so let's put that back in. U is equal to x squared minus 3x plus 1 to the fourth power times du. And we know that du is equal to 2x minus 3. So that's how we use u substitution to make this a little bit easier. So for now, we're not going to make you expand this. I just wanted you to get used to how we use u substitution. So let's try another one. We're going to use u substitution again. Oh, we already solved this using u substitution, so we can move on from that. Now, in most cases when we're trying to find u, because they don't often give it to you, you use the innermost function and usually use it to be the most complicated part. So if we take a look at the following problem here, when we're trying to find y prime should just be u times du. Well, let's change that. When we're trying to find y prime, we take the derivative of the outer portion. So the outer portion here is sine. 7 minus 5x is u, correct? So when we find y prime, we're finding the derivative of sine. So the derivative of sine is cosine of u times du, because we have to multiply by the inside, the derivative of the inside. So we know that this is cosine of 7 minus 5x times the derivative of u is really just negative 5. So our final answer is negative 5 cosine 7 minus 5x. So again, the chain rule, that's when we differentiate the outside function and then multiply by the derivative of the inside function. Now notice I say repeat if necessary. Sometimes you're going to have multiple chains inside. That's why it's called a chain link, because there could be multiple links in here. So we're going to do example 2. Now, in this particular case, you could do the u substitution if you like, but you don't have to. For this particular case, I'm going to try and do it without it, just to give you an idea. Now, when we take the derivative of y prime, we're looking at the function, we're looking at the outermost, and what we see in the outermost is this fifth power. So we're going to use the power rule. So that becomes 5 times 2 plus cosine x to the third power to the fourth. So notice we took that fifth exponent, we brought it to the front, and we subtracted 1. So 5 minus 1 is 4. And notice all we've done so far is use the power rule. The chain rule comes on the next part when we multiply by the derivative of the inside. So if we multiply by the derivative of the inside, we need to find the derivative of each. So the derivative of 2 is 0 because it's a constant. The derivative of cosine x to the third is negative sine x to the third. Now that we found the derivative of that, we still had the x to the third power. So we now need to multiply by another chain or another link and look at the inside. So we have x to the third power. We need to then find the derivative of that, which is 3x squared. Final answer here should turn out to be 15x squared. 2 plus cosine x to the third all to the fourth power times negative sine of x to the third. We can actually do this one last time. Pull out the negative from the sine x and say we have negative 15x squared 2 plus cosine x to the third all to the fourth power times sine of x to the third. And that's your derivative. So notice we had 3 chain links here. Let's try another one. Remember, we always want to start off on the outermost portion. So here goes. We have y prime. We're going to find the derivative of the outside. So that's cosine of 12 minus 3 cosine of 2x squared. Notice that we only found the derivative of the outermost portion. We took the derivative of sine, which is cosine. Now we're going to multiply by the derivative of the inside. So the inside is this part that I'm now coloring in blue. So the derivative of the inside is now, well, derivative of 12 is 0. Derivative of negative 3 cosine. Derivative of cosine is negative sine. So this is going to be negative 3 times negative sine 2x squared. Notice the 2x squared did not change. Now we're going to find the derivative of the innermost portion, which I'm now going to color in red. So the derivative of the inner portion is now 4x. And now we are left with cosine 12 minus 3 cosine of 2x squared times 3 sine 2x squared times 4x. Notice that the sine of negative 3 times negative sine became positive. Simplifying one last time, this becomes 12x times cosine of 12 minus 3 cosine of 2x squared times sine of 2x squared. And that's your final answer. Again, I know this might be a little weird. That's why we're going to give you plenty of time in class to practice and ask lots of questions. So let's try another one. So we're going to find the derivative. Now, looking at the outermost portions at the farthest left and the farthest right, we have what looks like a power rule. So if you want, we can use u substitution in here again and say, hey, look, we have u. We're going to let u equal sine of x minus cosine of x. That means du, the derivative, is equal to cosine of x plus sine of x, because derivative of cosine is negative sine. And we already have a negative, so that should make it positive. So now we have u to the fourth power. So g of u equals u to the fourth, and g prime of u is equal to 4u to the third power times du. So 4 times sine of x minus cosine of x to the third power times cosine of x plus sine of x. And that's your final answer for that. So sometimes we're going to have to look at slopes of parameterized curves. Now, these all refer to parametric equations, which you'll have to cover more so in Calculus BC, but it is covered slightly in AB. So I wanted to make sure we talk about that for a little bit. So parameterized curves basically just take two functions and split them up and all write them in terms of t. So that means we could take one equation that was something like y equals mx plus b and write them as 2, as in like y equals 3t plus 4 and x equals 2t minus 1. So essentially we're adding another variable in here. Now it says if all three derivatives exist and dx of dt is not equal to 0, then we know that dy divided by dx is equal to dy divided by dt, all divided by dx of dt. This is a complicated way of saying, hey look, if we have two functions that are not equal to 0, where the dx is not equal to 0, you can write this as a slope function. So let's look at this together. So we're looking at two parametric equations. Notice we have x equals, we have y equals. They want us to find the slope of a tangent line at t equals negative 1/6. So that's what we're going to do. Now, in the past, we have always had equations that look like y equals something x. And we found the derivative, and that gave us the slope of the tangent. In this particular case, we don't have that because they're parametric equations. So this is actually a lot easier than it looks. We're going to find the derivative of x and y. So here we have x prime equals cosine of 2 pi of t. Let's throw in a pi, otherwise it's just like I'm saying pit. So now we have our 2 pi. So 2 pi of t. Remember, because this is the chain, we have to multiply by the inside. So now that is 2 pi, because we took the derivative of 2 pi t. So now our x prime is equal to 2 pi cosine of 2 pi t. And that's where our x prime is. Let's find our y prime. Y prime is equal to negative sine of 2 pi t times 2 pi. Notice derivative of cosine is negative sine, and then we kept the inside the same and multiplied by the derivative. So now our y prime is equal to negative 2 pi sine of 2 pi t. So this wants us to figure out what it is at t equals negative 1/6. So now what I'm going to do is I'm going to substitute negative 1/6 in there. So 2 pi cosine of 2 pi times negative 1/6. We know we have x prime is equal to 2 pi cosine of negative pi divided by 3. And don't we know that pi divided by 3 is the same thing as 2 pi divided by 6? So really we have 2 pi times, and then using our unit circle, cosine of negative pi divided by 3 should be equal to 1/2. So really, x prime is equal to pi. Now let's do the same thing for the y prime. So y prime is equal to negative 2 pi sine of 2 pi times negative 1/6. Y prime equals negative 2 pi sine of negative pi divided by 3. So we know that negative pi divided by 3 is really just negative 2 pi times sine of negative pi divided by 3 is negative square root 3 divided by 2. So because we have the divided by 2, the 2's cancel out. The 2 on the numerator, 2 on the denominator, we are left with negative pi. Actually, yeah, we have negative pi times negative square root 3. Simplifying one last time, we end up with pi square root 3 because the two negatives on the inside of this line cancel each other out. And so here's our final answer for y prime. Finally, they want to find the slope. So couldn't we just find dy divided by dx? Because the d stands for delta, or change in. So it's really just change in y divided by change in x. So I believe that's equal to dy is equal to pi square root 3. And our dx is equal to just pi. Therefore, our final answer should just be square root 3. That's the slope of the tangent line. So let's have you try this one. I'm going to solve it with you, but try and pause it and do it on your own. This time we're going to do it a little faster. So this time we're going to find x prime. X prime is equal to 6t squared. And we're going to find y prime. Y prime is equal to 4t to the third power. So now we're going to substitute negative 1 in there. So we get 6 times negative 1 squared. X prime is equal to 6. Now we're going to do the same thing with the y values. We're going to substitute that 1 in there, negative 1 in there. We're going to get 4 times negative 1 to the third power. Negative 1 to the third power is just negative 1, so y prime is equal to negative 4. Now we want to find the slope of the tangent. Again, that's dy divided by dx. And that is equal to negative 4 divided by 6, or just negative 2/3. And that's your final answer. So I know I gave you a lot in this one. We'll have lots of time in class to practice. Let me know if you have any other questions, but that's all for now. So I'll see you guys next time.